Good morning, all. I welcome you for the lecture series in the course Measurements and Manufacturing Techniques. Today, we are here to see linear measuring instruments. As the picture shows in the right side of the slide, there is a giraffe. Why we remember giraffe more than other animals? Like giraffe is tall. So everywhere measurement comes in life, not only in the nature. Um, Let us empathize this topic whenever a new baby is born. So this newborn baby is being taken into a weighing scale to understand the weight of the baby that resembles the growth. And as the baby grows day by day, we are always checking our body weight and height. So then it is put into something called as body mass index, which is very important for the growth. So everywhere in life, we need some linear measurements for sustaining the growth. So let us see what are the linear measuring instruments in this particular lecture. And today's topics for discussion is why linear measurements are important and what is the classification of instruments, various measuring instruments, application, and conclusion. So the significance of linear measuring instruments plays in all the areas of engineering, where it starts from construction to the personal activities. So it ensures structural integrity and alignment, and it aids manufacturing, which facilitates precise production process. And in navigation purpose, we use a compass, which is a linear measuring instrument which aids in accurate positioning and route planning. And in science, it supports data accuracy in experiments and personal activities. It enhances daily task and efficiency. So from our lower standards, we are studying this direct measuring instruments, that is vernier caliper. We all know very in depth about how this instrument works and what are the uh, available parts in this instrument. So let us just recap. That is vernier caliper, which is a vernier scale and locking screw, main scale, blade for depth measurement, upper jaws for external measurement, and lower jaws for internal measurement. Not only vernier caliper, we have micrometer, height gauge, and depth gauge, which follows the same protocol for measurement. And indirective and comparative measuring instruments we have. For example, if you want to measure dimension which is 30 mm, and if you have the number of components is more, like 1,000 components to be measured in a shift that is 8 hours, then we need to go for this kind of comparative measurements. We call it as comparators. So we use dial gauges for this and slip gauges to set the basic standard of particular measurement. And we also have optical comparator, which magnifies the difference for the accuracy. And precision reference instruments are nothing but using high accuracy setting and calibration. So what is calibration in linear measuring instruments? Like whenever we use measuring instruments, we need to ensure that it has no error during the measurements, and the measurements are very accurate. So to maintain the precision and accuracy, we use something called as slip gauges. So slip gauges are the accurate measuring blocks, which we call it as master blocks, master gauge blocks, which is also called as Johnson's blocks, which is used for particularly going for calibration purpose, and we always end up with maintaining the zero error. And sine bar is one of the major components which uses slip gauges to measure the angle between them. Here the angle is theta and the angle between them is sine theta, that is opposite by hypotenuse. And we use N standards also for the precision reference instruments. So let us summarize the linear measuring instruments so far we have studied and see, for example, vernier instruments is used to measure linear length, width, and everything. And micrometers are used to measure diameter, OD, ID, everything. And gauges, of course, it is to measure the whether the component is selected or not selected. So go gauge or no go gauge. And comparators, as usual, we said about that comparing the standard value with the available value in the drawing. And we have some specialized linear instruments also, which we'll be seeing in the forthcoming lecture series. And we have a small challenge here to find out the reliability of instrument. We have vernier caliper as well as outside micrometer. So find out which instrument reading is more reliable and why. Is the shaft dimension within the tolerance limit? And the third question is comment on the precision of vernier caliper versus micrometer in this case. And we have a small quiz here for you. Hope the quiz is very simple and easy one. You could make it. So these are all the references for the video. Thank you all.